Hello, my dear students. In this session, we will learn what happens if alternating voltage is applied to a pure capacitive circuit. Okay, AC applied to a capacitor. We will consider a capacitor of capacitance C, and this capacitor is connected to a alternating source or AC voltage. So the applied voltage is V. Okay, applied alternating voltage is given by V is equal to Vm sin omega t is the applied voltage. I call it as equation number 1. Now some current flows through the circuit. Okay, say at a time interval at a particular instant t. Okay, at a particular instant t, the charge stored in the capacitor Q is equal to C into V. Charge stored in the capacitor is C into V. That means what is the potential across the capacitor? Potential across the capacitor is Q by C. Potential across the capacitor is Q by C. Now this capacitor and this alternating source, they are connected in parallel. When they are connected in parallel, potential should be same. So applied voltage is V, potential across capacitor is this Q by C. They should be same. So therefore, I equate these two equations. Q by C is equal to Vm sin omega t. Okay. Q by C is equal to Vm sin omega t. Now what is my aim? I have to calculate the phase difference between voltage and current. So I have written one equation for voltage. Now I should write one equation for current. How to write equation for current? See, here Q is there. Okay. If you differentiate that equation, you will get dq by dt. What is dq by dt? dq by dt is current. So therefore, I just rearrange this equation. Q is equal to Vm into C into sin omega t. Now I differentiate this equation. Differentiating this equation on both sides. What happens? dq by dt is equal to differentiation of this. So these two are constants. So what happens? Vm into C into differentiation of sin omega t is cos omega t. Differentiation of sin omega t is cos omega t. So what is dq by dt? dq by dt is I current. I is equal to, now here I have done a mistake. What is differentiation of sin omega t? Differentiation of sin omega t is cos omega t into omega. Correct now? If you remember, what is differentiation of sin ax? Differentiation of sin ax is cos ax into a. Correct now? Cos ax into differentiation of ax, that is a. So differentiation of sin omega t is cos omega t into omega. Correct now? Cos omega t into omega. Or I can write this as Vm into omega c into cos omega t. So now this is the equation for current. Now I cannot compare this Vm sin omega t and this Im cos omega t, because one is sine function, other is cos function. So what I'll do, I'll write this cos in terms of sine. So we know allied angles. Now here this is Im. Okay, I is equal to this omega c. I'll take it to the denominator. So what happens? I is equal to Vm divided by 1 by omega c. This is very important. This step is very important, because when you apply alternating current to a resistor or inductor, you might have seen here one equation will come. In the first derivation, Vm by R will come. In the second derivation, Vm by omega L will come. So Vm divided by something should be there, so that it can be treated as analogous to resistance. So you have to write this. Okay, divided by 1 by omega c into cos omega t. Cos omega t can be written as sin. Cos omega t can be written as sin omega t plus pi by 2. Sin omega t plus pi by 2. Because sin 90 plus theta is cos theta. Sin 90 plus theta is cos theta. So therefore I have written it as sin omega t plus pi by 2. Or this can be written as I is equal to Im I is equal to Im. This is treated as peak value of current, Im into sine omega t plus pi by 2. Okay, now see what is the phase of voltage? Phase of voltage is omega t. What is phase of current? Phase of current is omega t plus pi by 2. So who is leading? Current is leading because current is omega t plus pi by 2. That means in capacitive circuit, current leads voltage by pi by 2. Current leads voltage by pi by 2. Say, okay, this is equation number 2. From 1 and 2, we see that current leads voltage by pi by 2. Phase difference between current and voltage is pi by 2. Phase difference is pi by 2. Now, how do we write a phasor diagram? How do we write a phasor diagram? What is equation for voltage? V is equal to Vm sine omega t. What is equation for current? Current is equal to Im sine omega t plus pi by 2. Correct now? Okay. How to represent voltage phasor? So this is voltage phasor. Correct. This is voltage phasor. What is phase of voltage? Phase of voltage is omega t. Okay. This is simple. Next, how to represent phasor of current? Current is omega t plus pi by 2. Omega t plus pi by 2. So this should be the current phasor. So that phase of current is omega t plus pi by 2 plus pi by 2. So this is how you write phasor diagram. Or if you want to represent this sinusoidally, voltage or current is taken along y-axis, time is taken along x-axis. If this is the variation of voltage, okay, this is the variation of voltage. How does the variation of current look like? Current, okay. What does the variation of current look like? Variation of current should look like this. Why? See, voltage is maximum here. Correct now? Voltage is maximum at pi by 2. Voltage is maximum at pi by 2. So this is 0, this is pi by 2, and this is pi. Voltage is maximum at pi by 2. So this is the variation of current. This is the variation of current. Current is maximum at 0 degree only. Means who is leading? Current is leading. Current is leading voltage by pi by 2. Now here the derivation is completely over. But the thing is, if you, what is the equation of Im? Equation of Im. Im equal to Vm divided by 1 by omega c. Correct now? So this term is analogous to resistance, because what is I? I is equal to Vm divided by R. In the case of pure resistive circuit, I is equal to Vm divided by R. So this term is analogous to resistance. What does it mean? 1 by omega c is the opposition offered by the capacitor to the alternating current. 1 by omega c is the opposition offered by the capacitor. So 1 by omega c, we call it as capacitive reactance. We represent it by XC. Capacitive reactance is equal to 1 by omega c, or that is equal to 1 by 2 pi Fc. Okay, so this is capacitive reactance. Now, in the case of DC, okay, for DC what happens? For DC, direct current, what is frequency? Frequency equal to 0. Frequency equal to 0. If frequency equal to 0, what is capacitive reactance? Then capacitive reactance is infinite. Capacitive reactance is infinite. Means opposition offered by capacitor for direct current is infinite. Means DC cannot flow through capacitor. That is why you might have observed in current electricity chapter, in any of the branch, if you come across capacitor, you just leave that branch, because capacitor stops DC, because its capacitive reactance or opposition to the flow of current is infinite. Okay. So as far as AC is concerned, alternating current is concerned, it has got some frequency. As the frequency increases, capacitive reactance decreases. So this is what you have to understand. Hope you have understood this derivation. Applied alternating voltage, equation for applied alternating voltage is this. Now we have to write an equation for current. So what we have done, we have we wrote an equation for voltage across capacitor, that is Q by C. Since those two are parallel, we equated these two equations. Then we wrote Q by C is equal to Vm sin omega t. Then we got a hint that I want an equation for current. So if you differentiate Q, you will get dq by dt equal to current. So we differentiated it. And then cos omega, when we differentiate sin omega t, we got cos omega t into omega. So we had to write equation of current in terms of sine. So therefore we wrote cos theta is equal to sine 90 plus theta. Okay. Then we got an equation I is equal to Im sin omega t. So phase of current was found to be omega t plus pi by 2. Phase of voltage was just omega t. So what is the phase difference? Phase difference is pi by 2. But who is leading? Current is omega t plus pi by 2. So therefore current leads voltage by pi by 2 in the case of pure capacitive circuit. And this is a phasor diagram. Phase of voltage is omega t. Phase of current is omega t plus pi by 2. Plus pi by 2. And this is the, then we wrote the equation for Im. So this is the extra thing. Okay. Im is equal to Vm divided by 1 by omega c. So this is analogous to resistance. So therefore this is the opposition offered by the capacitor to the flow of AC. We call it as capacitive reactance, and that is equal to 1 by 2 pi fc. In the case of DC, since the frequency is 0, capacitive reactance is infinite. Therefore capacitor stops DC. In the case of AC, capacitive reactance is inversely proportional to frequency of AC. Hope you understood this derivation.